Okay. Wait mga palangga kong hitad. Wait ha. Sit up kayo. Check. Ganon. Wow. La. Uy. O, diba? Okay. Okay, I'm coming back to discuss our topic for today. Welcome back to my YT channel. This is your science, health, safety, and music vlog. So we need to end the biochemistry topic with this last topic, electron transport chain. So what we will be understanding here is the last step of aerobic cellular respiration, and this is also the last process in order we can obtain energy. Okay, energy, and this energy specifically coming from the adenosine triphosphate ATP, which is the main source of energy in all living cells. Things like that. And along with that, ATP, water, and carbon dioxide coming from the general chemical reaction of the glucose plus the rapid oxidation of oxygen in combination with the light energy of the sun. Okay. And the chlorophyll also interaction from the plants, and then it will be absorbing by the light energy, and it will go through your product. Things like that. Okay? So we need to discuss now the general process of ATP. Step 1. Okay, where is my marker? So marker, where are you? Okay. The first step is the transport of electrons. I will just put that here in the whiteboard. So can you read or not? It is visible or not? And readable or not? Readable, right? Okay. So this is the, okay. Guys, transport and transfer is just the same, huh? The transport, okay. But transport is more general because it doesn't mean only transfer. It could be going back again and come back again. So let's just use the general term. Transport of electrons from FeDH2 and NADH to protein complexes, which is our electron carrier. Okay, which are our electron carriers. Okay, transport of. The clue here is electrons, okay, from, okay, FATH2 and NADH to protein complexes. Wow, protein complexes. Complexes meaning a set of multiple membrane proteins, and really that is a very complex protein. Things like that. So protein complexes, because it involves a lot of processes, things like this. So protein complexes, okay, okay, as the electron carriers. Okay. Now, the purpose of your electrons, this will be transferred so that we can produce protons, things like that. And these protons are responsible for the energy that we have. Okay? So number 2. So again, transport of electrons from FeDH2 plus NADH to protein complexes as the electron carriers. Okay? Like that. 2, pwede po natin to produce energy. Okay. Okay, provide action to produce energy. So FeDH2 means, okay, flavin adenine diphosphate. Okay, NADH, nicotinamide adenine, okay, dinucleotide. Okay, so again, so look at the word itself. Okay, so F stands for flavin. Okay. So D, what would be the D here? Represents the dinucleotides. Okay, dinucleotides. Okay. And nucleotides composed of a lot of amino acids in a prescribed order, nitrogen, hydrogen, things like this. Okay, so flavin, adenine, dinucleotides plus nicotinamide, adenine, dinucleotide, things like that. Okay, so this is our enzymes helper. Okay, this is not the main enzymes. This is an enzymes helper to produce the synthesis products. Okay, number 2. Our number 2, okay, this electrons that has been carried, okay, so it will generate protons. Okay, it will generate protons, and these protons will be pumped out in the intermembrane space to the matrix. Later we can understand it by drawing. First statement, okay, electrons, okay, generates meaning produce, right? Electrons produce, or let's say yield, okay, or yielding, okay. Electrons generate, so this is generate because our electrons are plural. Electrons generate, okay, protons, okay. These protons, okay, these have PHESE plural. These protons, okay, will be pumped out. So basically, we have the pumping machine inside our body, natural pumping units, things like that. It will be pumped out from intermembrane space. Later, I will be drawing to you, not exactly the accurate drawing, so that we can have only an overview what it looks like to have a cell membrane like that, okay? From intermembrane space like that, okay? To the matrix, okay, like the matrix of the cell membrane. So understood, because the matrix is in the cell membrane. We don't need to put in the cell membrane, but understood if you try to be complete only. So electrons generate protons. These protons will be pumped out from intermembrane space to the matrix membrane. Okay, like that. Okay. Number 3. Okay. Okay. The protons that will be pumped out. The protons that will be pumped out. Okay, take note how the sequence that will be pumped out will yield, okay, electrical chemical gradients. Electrical chemical gradients. Okay. So electrical chemical gradients, so in short, these are electrochemical gradients. So you can say also electrical and chemical gradients, but if you have tried to shortcut that one, it is electrochemical gradients. You don't have to say electra, okay, because it sounds awkward. So here, the abbreviation of electrical is electro, not electra. What? Pwede mo gawin na? Electra, electrochemical gradients, it looks like, awkward to hear. So it's an electrochemical gradients if you try to combine. If you try to separate electron and chemical gradients, that is driven by protons, okay? The protons that will be pumped out will yield electrical and chemical gradients, okay? So, to create electrical signals, things like that. Because if there's no electrical signal, how can these protons will come out, will come in? The protons that we are referring here is the potassium and sodium, okay? You got the point. So, just like we eat banana, rich in potassium. Okay, we eat, we put salts in our food menu, sodium chloride. And that sodium ion, okay, will be directing toward inside our nervous system, okay, then it will be used here in the different cells of our vital organs to be pumped. The sodium ion, it will separate the chlorides. Okay, you get the point. So, ganon. Number 4, the electrical gradients protons like that, okay, or the protons itself, okay, the protons that travels, okay, travels, okay, in the intermembrane space. Did you really understand that by drawing, huh? Intermediate space, okay, like that, okay, will be converted to ATP, adenosine triphosphate, okay, where the F1, F0 ATP synthase enzyme. Okay, so it needs an enzyme to produce an ATP in the last, but actually there's also intermediate enzymes here, but I just not discussed because that is not the main point. So the main point will be in the last stage that this enzyme is very useful. Okay, ATP, F1, FO, ATP synthase. The function of this is a mitochondrial, okay, enzyme that catalyzes the synthesis of ATP, this one, adenosine triphosphate, from adenosine diphosphate and inorganic phosphates. Okay, because the point, so before it will come to ATP, it's still ADP plus phosphates, like that. That's why it's ATP, because due to the presence of phosphates. Okay, you got the point? Next shot. Okay, so after that, it will yield an ATP, it will create a phosphodiester band and releases ATP. This is the type of bond that's responsible to produce the ATP molecule. Phosphodiester bond, meaning the bonding of the molecules to produce ATP. But we can produce this ATP by having this F1, FO ATP synthesis. Actually, this is also called, based on my research, that is not popular, but in the, let's make sure, because we don't know it will come out in the examination. This is mucosmosis process. Okay, here, it looks like difficult, right? Mucosmosis process. Okay, things like that. So, blank is a process, in which the protons will travel through the rigid spaces that will convert the ADP and phosphates to ATP, okay, to produce this energy. Okay, energy meaning the ATP. The answer will be mucosmosis. Okay, or you can simply call that it is an oxidative phosphorylation. Okay, and here, because we add phosphate, so that's an indication. See, ADP plus phosphate. So phosphate meaning phosphorylation. Get the point. So this is the four basic process in our electron transport chain. Like that. O diba, nakakaloka mga palaga kung itan. Okay. Now, gets copy already? Okay, or you have to write in a sheet of paper. Things like that. Okay. This is electron transport chain. You get the point? So if you treat thread, that is only general, but actually it produces ATP also and water. And then, never mind with the carbon dioxide because it will be produced by your Krebs cycle in step number 3, carbon dioxide. Okay? But the ATP will focus here and the electron transport chain, but ATP also can be produced in the Krebs cycle. It's always starring, it's always appearing in as Krebs cycles from electron transport chain. Okay? But it is not appearing in the glucoses. You get the point? Sa starting point niya. Okay? So there is. Okay. So, it is evident in our discussion today that, it needs electron carriers, okay, to produce these protons. Okay, if that is the case, okay, meaning to say, it is losses electrons, right? Tama ba? Okay, so that it will produce protons. Okay. So this is undergoing oxidation. process. And so we have oxidative phosphorylation. And in fact, this is also adding oxygen in our system, which is really oxidation, rapid oxidation, because this is a part of aerobic cellular respiration. So that is your identification. Don't think for a reduction here. Think of an oxidation. The first thing to remember, because it's very easy that there's an aerobic cellular respiration. Aerobic means oxygen or air. And electron transport chain is the step number 4. Okay. Another example also, okay, for this, the ATP, charot. Okay, that's the point. So, muna siya adenosine triphosphate. Hindi mo na siyang timanaan. Okay, that's the point. Huwag yun siya curly guys na makalang akong kita. Okay. So, kung papasukin, papasok ko yung red way. So, okay, ganyan. Tararat, ganyan. Tararat, okay. Tararat, okay. Tararat, okay, ganon. Okay, ganon. Okay. Okay. Ang tagal naman ang erase yung ano. Wait for a while. Ay, nakakaloka. Oh, sige. Sige pa ba kayo? Mga palangga o hitad? Oy. Maklaro ba? Okay. So, gano'n na siya mga palangga hitad, ha? Okay. Now, when we mean an oxidative phosphorylation, some books are telling that this is tantamount or equal to or similar or parallel to electron transport chain, because without oxidative phosphorylation, we cannot produce ATP. That's why they are equating this one as equal. But if we distinguish the little difference, okay, so the definition will matter a little bit. Because if you try to determine the definition of ATC, it looks like comprehensive if you will just state the definition of the oxidative phosphorylation. Because in the oxidative phosphorylation, focuses on the phosphate. But for the electron transport chain, it covers all. Okay, from step 1 to step 4. That's only the difference. But if we try to put that in examination, it will be just okay. Just try to consider how it is being phrased in the question. Things like that. You have to remember. Okay, like that. So you can feel the question if it is really the same or not. The way how it is being phrased, the question. So if you feel too much lengthy, the description, and then does not go direct, it could have been electron transport chain only. But if the definition is very direct to the point, for example, oxidative phosphorylation, okay, is the process in which the electrons transported from FeDH2 and EDH from protein complexes or electrons carrier will be used in the electron transport chain by adding inorganic phosphates from adenosine diphosphates to produce ATP. So this is only oxidative phosphorylation. But if it states a very lengthy, phrases that involves the whole scenario from 4 that I presented a while ago, they'll choose ATC. But basically, they have the same, target of explanation. Only how it is being phrased matters also. You get the point, that you can feel that in the examinations. If this will come up in the examination under science, physical and chemical principles. Okay? Though this is highly related to biochemistry, but sometimes also we cannot also predict the people that will make the questions. Because the point, as long as it is related, they will put that also. Okay, because I remember when they were putting lanolin in examination before, in our board examination, in day 2, he said, which of the following does it belong to the group? A, linoleic acid, oleic acid, that lanolin, things like that. Klaro kang lanolin, because lanolin is not an oil. Okay? So it's like, that is a substance found in the skin of a sheep, something like that, and it's being processed to a certain product, blah, 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 so and so, as a moisturizer, things like that. So that's lanolin. So, klaro kayo, lanolin is different, but it's not covered by, our subject, but I think it's covered with the chemical process industries, but it's related to pharmaceutical chemistry, okay, or cosmetics. Just like glycerin. Okay, glycerin is a component, one of the component of making soap, SOAP. Okay, so things like that, along with stearic acid. So they will put that there to produce the soap as an ingredient. So, though it has been covered in the chemical process industries as one of our subjects in chemical engineering, but it's focusing more on the pharmaceuticals, like that. Okay, because pharmaceuticals also are discussed also in our CPI. Okay, nakaloka. Okay, but we don't have more on biochemistry. That's why. You get the point? Things like that. Okay, naklaro na natin na to. So in short, guys, our electron carrier's purpose is to generate the protons. Okay, and these protons will act as our electrical chemical gradients, okay, to be used in synthesizing ATP, our main source of energy from ADP and organic phosphates, things like that. Okay, you get the point? No. So if I have your reaction, let's take general, guys, because ATP, you can never memorize that the structure is very complex, really. You can only see that in the monitor screen of your computer. It's so many complex, what do you call this one? Like a polycyclic closed chain. Just like a chlorophyll. Okay, you cannot memorize if you want to memorize, you can memorize, but it takes a longer time to memorize, which is having no relevance at all. Because most of the questions will tell you, write the structure of this complex. No, it's not like that, especially in organic chemistry. So no need to, if you know how to do that, then advantage. But most of the times, based on my experience, it won't be asked in a question that you're trying to draw the structural formula of these. Though it doesn't like that, I do only sometimes like that into the substances that are not more complex and very basic to understand. Sucrose, fructose, like it's very easy to do. That's not complex. You get the point? If it is complex, you don't need to memorize. Understand only the general formula. So that's what we are trying to do here now. Okay. ADH, okay, plus inorganic phosphates. Take note, guys, phosphates is always inorganic. This is not organic substance. Okay. And these are basically salts from the word ATES, ATI. If you found a substance that have ATI in the last three letters of your word, that is sure in organic chemistry, right? It doesn't hold through in organic chemistry, but that is inorganic. So we put labeling inorganic phosphate to make it sure. Okay, inorganic. Okay, like that. Okay, it will synthesize to ATP, but before releasing ATP molecules, okay, it will be having a phosphodiester band. Phosphodiester bond, like that, and catalyzes the reaction to produce ATP. You get the point, and our enzyme is F1FO-ATP, okay, synthase. Okay. Just remember the word synthase is for chemical reactions or biochemical reactions that undergo synthesis. Because the term synthase is coming from the word synthesis. That's why synthase. Since we know that enzymes ends in letters A, S, E in the last three letters in the word, so you should think like that always. So, okay, nobody teaches me to do this. Okay, I did that research is also in the Google search. As long as I understand that synthase is coming from synthesis, automatic, pasok sa banga. Okay, you get the point. So, muna siya sa mga process ng mga synthesis, usually your enzyme will have synthase. But not all, but usually have. Okay, so another technique only. Okay, because sometimes it will be dehydrogenase. Okay, you get the point. Or kinase. Because phosphate, if you add phosphate also, that is a process called kinase. It depends on the situation. If there's a multiple choice in the question, then go ahead, analyze well. Okay, because we cannot feed you everything. Okay, it's gonna be like your, what do you do this one? Your natural mental capability will work in the actual examination. Okay, things like that. Okay, so mga yung anak. So our enzyme here is F1, F0, ATP synthase. Gonna to produce ATP, and before that, it will be yielding a phosphodiester bond. Say phosphodiester. Okay, ester is a salt, equivalent to the inorganic salt, which is a phosphate. So normally it will produce an ester. Okay, and phospho, because we are phosphates. Okay, things like, and di, because our raw material is di. Adenosine, di. Okay, so we have also phosphodiester bond. So you can derive from the raw materials you added. You need to memorize. Okay? So that it will not complicate. Okay? If you're keeping always to memorize everything. You get the point? And the chances is you will lost in the actual examination. You get the point? So, mo na siya ang hita po. Now, we will discuss now the drawing or the illustration. Okay? So, we have now the statements and the chemical reactions. Now, we draw what's really happening in our cell membrane, particular in the mitochondria of our cell. Okay, all of us guys have mitochondria cells, in our vital organs. In here, this is only for one cell explanation. Since we have trillions and trillions of cells, so that's why it's discussed that if we try to connect all this, okay, sample DNA, it will reach to the universe. Okay, if we connect all the length of our DNA, it will reach to the universe because it's very lengthy. We have trillions of cells. And this discussion only is referred only to one single cell in a particular vital organ. Imagine. So it's very, very lengthy. Okay, so nobody do that. This is only trying to point it out how very long really is our DNA. Okay, you got the point? Ganon. So ako stress ang DNA because we need also phosphorus there in the formula. That's coming from the ATP, obviously. Okay, you got the point? Ganon. So, we draw here, for example, this is our cell membrane like this. Drawing. Who loves drawing? Engineering Drawing 101, Cebu Institute of Technology University. Charot. Charot lang. This is what we call in our engineering ES 101. Engineering Drawing. Charot, charot. Like this. Too much circle, like children. Multiple of circles. Okay, like that. And compacted with each other. Compact. Okay, like this. Like so this is our cell membrane. The cell membrane, guys, is also called as the plasma membrane. Okay, do not be confused. It's just the same, but not commonly used the plasma, always cell membrane. Okay? Like that. Kasi papakuhan mo, then, plasma naman, wala na nag-apply ang theory. So that's what I mean. Okay? You get the point. Ano siya ang atong cell membrane. Okay, the top portion. Then we have ganon. So we have here the bilayer. Okay, and we have here membrane also. Okay, like that. Okay? So this one. Here. So just like this, okay? This is our cell membrane. Composed of so many circles. There's also a cell membrane in the lower portion. Ganon. Okay. Now this is our mitochondria. Okay. Inside the mitochondria, this is in our mitochondrial matrix. This one. Diba? Nag-draw kong cell. Dito na siya sulod sa mitochondria. May tabo. This one. Okay. So imagine how small is that already. I'm just expanding that there so that we can understand it macroscopically. Wow, microscopically. I use my macroscopic in an adjective way. Macroscopic. Macroscopically. Wow. I-insert yun ako. So, macroscopic. You get the point? It's gonna a larger perspective. It's just very small. Cannot be seen in our naked eye. Guys, you can never see a cell in your eyes. Okay? You can only see that through microscopic technology. Okay? Because that is invisible by the eyes of the human being. Very, very, very small. Okay. Now we have here the two layers. Here is the space, what we call intermediate space. Here. Or intermembrane space. Okay. Here is the matrix or the mitochondrial matrix. This is inside the mitochondria already, ha? Okay, mitochondrial matrix. Okay. So based on research also, okay, here it is having more protons concentration in the downside. More protons concentration. Okay. And then in the upside, we have lower protons concentration. Okay, lower protons concentration. Like this. Okay. Ganon siya. Okay. So here is the center of our intermembrane, like this, like this. Here, the protein complexes, of course. Here. Okay, like this, like this, like this, like this, like this. Okay. So we have protein complex 1, protein complex 2, protein complex 3, and protein complex 4. It's gonna be like that. Now to understand it further, so that it will not complicate our discussion, we need to introduce the enzymes first to have an understanding. So the first enzyme that will be donated, or like donated, will react to the electrons to synthesize further the substance. First is the coenzyme Q. Coenzyme Q molecule. Number 2 is the first enzyme. Second enzyme will be the cytochrome C. Because this is very important to synthesize further these electrochemical protons. Okay? Cytochrome. Because without these enzymes, we cannot produce energy. Okay? Cytochrome C. And the last enzyme will be the katakunin ninyo, F1, F0, ATP synthase enzyme. The production of the final stage, which is the ATP. Okay, ano show the reaction, di ba? Okay, that's the point. Ganon. Now, in our cell membrane, in the mitochondria, we have a pump. Here, pump. Just like a motor pump. Okay, pump here, pump here, pump here, pump here, and like this. I will draw this in a, black marker so that we can distinguish the pumps. Okay? This is applicable to all vital organs. For example, liver. Liver also have this. Heart. Heart also have this. Kidney. Kidney also have this. Okay, the brain also have this. And then you will try to produce, every vital organ produces ATP. And this is the source of our energy. That's why we can walk, we can eat, we can dance, we can sing, we can do work, dili-dili alatul, things like that. So without this process, we will die, obviously. You get the point? This is very important. But this is highly technical. Okay, nobody will try to dig us, but it is important to have knowledge. Okay? Because in this, we can really troubleshoot, or we will be diagnosing what diseases will come in. Even though we are not a doctor. So we can, it's going to be like this, it's happening for this. Like this. So that we have knowledge. So meaning to say, in this type of discussion, we don't need a doctor anymore to protect our health because we know the basics. Things like that. So that's the main purpose only. of this, vlogging, health science vlogging. Okay? So, let's say, putil galing gamay, masalindi ka sa doktor. So, mura man ko, di ba? You got my point? So, binata ka na siya, pag meron kayo sakit, magmaratol na ka. So, it's not like that. Okay, we need to understand really. Okay? So, di siya, grabe ka sakit, hindi mo na nag-feel na grabe. Okay, you got so mga anak ba? Okay, so it goes back to the knowledge, theory, and concepts in your mind's state of mind or mindset. Okay, got the point. So we have here matrix at the top, and we have intermediate space downside. And we have the pump here. Pump, 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 pump. We have 4 pumps that are built in your protein complexes. Okay, 1, 2, 3, 4 complexes. 4 protein complexes. So what will be happening here? Okay, and the last will be your last pump, will be the pump for your ATP synthesis. Here, the last. Things like that. Okay, so wala siya natabo. Okay. So let's make this clear pa. Basta, we understand na. Okay, for that. Okay, so here, we have here the actual chemical protein gradient na magtuyok-tuyok siya. Here. Because after pumping that out, it will be released, right? But this proton electrical chemical gradient will be, rotating in counterclockwise, so that it will be going out and then going to another protein complexes until to the next. If it will not rotate, so it will not build, okay, energy to be helpful in another synthesis from 1, 2, 3, 4. So it will be rotating here somewhere like that. Okay, so this is gonna be your here like that. Okay, so this will be rotating from, left to right. It's a counterclockwise. Okay, so tutuyok siya until the proton's electrical chemical gradient will be released, and then it produce an energy, will go to another protein complexes, and the last will be 4, and then until going to the last stage, which is the ATP synthesis. It's gonna be the process. Okay, so why it is moving counterclockwise also? Because of the higher concentration of the protons from intermediate spaces that will push this going out like that. Because if the bottom part is higher concentration, this will not move. Okay? If the matrix here is higher concentration and the bottom part is less concentration, it will not move. So that's why it should be from the bottom. That is higher concentration so that it will move. Okay, usually from higher concentration to lower concentration. From higher temperature to lower temperature. This is the concept of mass transfer and heat transfer, right? In our unit operations. So this will be applying here the little concept just like that. Here, from the higher concentration of proton ba? Yes, proton. It will move to the matrix from the lower concentration of proton in the matrix part of our cell membrane. That's why it will move. Okay, these protein complexes in a counterclockwise, releasing this proton electrical chemical gradient so that it will be catch in the last stage in the ATP synthesis reaction, and it will produce ATP in the last stage. Okay, things like that. So we will erase this because I need to emphasize the protein complex 1, protein complex 2, protein complex 3, protein complex 4. So I will illustrate the details of each protein complexes. Okay. Now, so I'm talking about protein complexes that if you're having lack of protein, what will happen? So we cannot yield 30 ATP, 38. Guys, because we need 38 atoms of ATP for our energy. Now, if you don't have proteins in our body, how can we have 38? You get the point? So, we need to have proteins in our body. Wala siya yung hinungdan that we need protein because it needed for our synthesis of ATP for the main source of our energy. So, Like that. The technical explanation. We need protein. And your answer all are opinionated. So, the factual answer for that, because it is very necessary as our main source of energy to produce ATP. And that is the technical answer, not opinionated. Because opinionated answer, you will answer so many things. Okay, that will be closer to that kind of question, but not real, the exact answer based on scientific theory and scientific evidence, things like that. You got the point? Okay. You got the point, mga palangga. Anak siya. Okay. Just like a question, what makes us alive? Di ba yung so many answer? Make us alive because of the food we eat, because the like this. But there are specific answer for that. Okay, you get the point. Because of the basic 5 elements: carbon, hydrogen, oxygen, nitrogen, and phosphorus. As simple as that. Ganon. Because these are all nutrients coming from the food we eat. So what that was but you are specifying. Because if you answer only very direct, because of the food we eat and the liquid we eat, and that's general statement. Anybody can answer that, even elementary. Okay? But if you go to the higher definition based on science, it's not like that the way you answer. Okay? It's based on technical, scientific information. Okay? Ganon. Okay. Get the point. Just like, what makes us alive? Your answer will be chemicals. Directly, one word, chemicals. Because all living organisms are made up of chemicals. Now, change your mindset and state of mind that if you mean chemicals, that is bad. No. Chemicals can be good or bad. Without chemicals also, we will die. Okay? But if we have more also of the chemicals, we will die. Okay? Kaya kinita ng oxygen, nitrogen, gas, air, these are all chemicals. These are all matter, occupies space that has mass. And matter can either be solid, liquid, or a gas, in which these are all materials composed of chemicals. So it's just the same telling that these are all chemicals. You get the point? Because materials that we have now, so we are surrounded with materials are made up of chemicals. It's just saying that we cannot survive without chemicals. So therefore, individuals are made up of chemicals directly. If you try to scrutinize the root cause, okay, root cause, why like this, and it will end up with chemicals. Why you are alive? Because we need food. What make that food? It is composed of this. Why it is composed of this, and it will goes back to chemicals? Because it's coming from ATP. Because it's coming to the chlorophyll. And this chlorophyll composed of carbon, hydrogen. So all are elements. As I told you, carbon, hydrogen, oxygen, nitrogen, and phosphorus. Okay. That's very clear. All nutrients have that elements. Okay? The vitamins also have that. Carbon, hydrogen, oxygen, blah, 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 so on and so. You are just don't know that because that is not your mastery, because that is not your specialization. You are not a chemical engineer, you are not a chemist, or you are not, your course is not related to science. That's why you take for granted. But if you try to be strict, okay, these are all made of chemicals, including your food supplements. Okay? Vitamin C, kabush, rice, everything you intake into your system are all chemicals. Okay. So we need to say, we will die without chemicals. Okay? And we also die more of, if we intake more of chemicals. So that's why the person will die. Okay? Because we are loaded of chemicals around us. And we are not mortals. Immortal. Diba? Mortality. Like that. We are not immortal. Okay? But we are all mortals. Sakto ba? Okay? Because mortal, meaning to say, dying, we will die. Immortal, we will never die. No, the definition in English, correct me if I'm wrong. Okay? Mortality, immortality. So the word is mortal and immortal. Immortal, I think, these are type of creatures that will never die. I think so, huh? And then these mortals are those creatures that eventually die after a certain specific of number of years they exist in the planet Earth. So we are all mortals, right? That's why in the reporting of the hospitals, there's a mortality rate. Okay, it talks about the death. That's why mortal, right? So another word of the medical science uses mortality rate. Actually, it's just the same of death records. Okay? Because all of us will die. So we are mortals, not immortals. Correct me if I'm wrong, pinabalik ko. Okay, you got the point. Wala na ako gi-prepare, guys. That's what come out in my brain cells now on the spot. Okay? You get the point. Anak siya. Any questions so far, mga palangga kung hitad? Okay, it's very clear now. We will illustrate pag yun siya. Here, this is our cell membrane. Like that, okay? Now guys, your cell membrane, guys, okay, magpalangga akong hitad. Okay. So, this will not become strong and solid without the presence of cholesterol. Phospholipids. The lipid family and the fats family. That's why we need fats to build up a strong and solid cell membrane so that our cell membrane could not be easily bleeding. There will be no wound strong enough. That's the purpose of cholesterol. And then they will also try to regulate what comes in the cell membrane and what comes out, and will act also as a cell barrier, meaning to say they are protecting our vital organs. That's the purpose of cholesterol. Okay, that's why all foods, majority, will be converted to fats later on. And what's the only problem is too much. Because of too much, then where can they go? That's obviously common. And they will go to that here in the stomach. Will go to that as bile fats because too much already, especially if your metabolism is very low. But this is very important, the fats family, cholesterol, phospholipids, like that. Okay? So, if you don't have enough cholesterol and fats, and then easily you will get abdominal pain, like that, and your body will be having a colon cancer in the future in your intestines. Okay, because you have lack of cholesterol, lack of fats, like that. But it's not usually the cases because we always eat every day that is more refined carbohydrates. I'm just talking with the reverse. Let's say this is the example that we have lack of fats, in which in reality this will not be happening because all of us are eating dili-dili alatun, rice, we know that. But you know, if it is the story, so that is the case. That's the purpose of cholesterol and fats. And then it gives us energy to fuel our metabolism. Meaning to say, it's just like, oh my gosh, heating and cooling system as our insulation process inside our body. In heating, cooling as the main process taking place in our metabolism. Okay? Burning calories and synthesizing calories. The cycle is going to be like that. Okay? So that is the study of metabolism. With another topic, biochemistry, but it will be also related to the discussion of biomolecules and macromolecules, such like this, okay? But we're dealing here with biological processes in our body. Okay, so we have here mga palangga kumitad, again, matrix, okay? Understood to be mitochondrial matrix. Here we have the intermembrane space, okay? Like that. Intermembrane space. Intermembrane space. And you have pump. Pump 1, we have the protein complex 1, like that here. 1. Okay. Pump 2 here. Ganon. Si 2 na ari siya. Okay? Si 3 diri ari po siya. Ganon. So this protein complex have pump, but except for two. The two will not have pump system. Huh? Maybe it will come up in examination. Which of the following protein complexes that has no pump system to pump the electrical chemical protons out to produce ATP? The answer will be protein complex number 2. Okay, so we have your protein complex number 4. Okay, diba? And then the last will be the ATP synthesis here. Sabi lang, mura siya sudlanan. Mura siya ganang kuan ba? Kanang sibot sa simbahan. Which is the ATP synthesis here last. Okay, ato na lang siya itagtatag sa ugyag-yag. Okay. You get the point. So understood na that we eat protein na talaga siya. Adequately, magmata na nga. Protein 1, protein 2, protein 3 in our vital organ and single cell consideration. Okay, ganon. Now, mga palangga ko ito, what is the step 1 there in our general? We said, electrons transported from FADH2 and NADH2 to protein complexes as our electron carriers will give energy. So this energy is from protons. Okay. So our keyword here is protons, electrical chemical gradient. Okay. Now if the question examination will say, Blanc is considered as an electrical chemical gradient in the pumping system of our vital organ. A. Proton, B. Neutron, C. Electron, E. None of the above. Your answer will be proton. Okay. Mailad mo sa electron because electron is used as a carrier to generate proton. So close ang electron ng proton. Okay. Neutrons, it has no contribution. The neutrons. Okay? Because that is neutralization. You got the point, anak siya. So, these electrons, okay, these electrons will generate protons. How? Okay, for example, we need to remember our minerals. Sodium, potassium, magnesium, and chlorides. Okay? So these four will really our substances in our nervous system. The central nervous system and the peripheral nervous system. The peripheral nervous system is a branch of this, okay, neurons going or connected into your spinal column, going to branches in different vital organs, kidney, liver, like that. But it is continuous to your central nervous system. But it belongs to one family, which is nervous system. And this nervous system will carry sodium, potassium, magnesium, chlorides to have electrical signal. Okay? So this electrical signal will obtain through this pumping in, pumping out, pumping in, pumping out, so that we can have electrical signal. By the time we reach the adequate level of electrical signal, this will activate our hormones. Okay, that's why hormones are called chemical messenger, or are the same as reporter in a TV news job. But what they are trying to send the message is all about chemicals. That's why chemical messenger, this hormone. This is the final stage from the food we eat. Okay, from all the substances we take from our mouth, going to esophagus, going inside, the product or the final output is the hormones. Or chemical messenger, no other. Okay? And this will be activated to the electrical chemical gradient protons because of the pumping of these protons from intermediate stage to the matrix. Okay, what will goes in is the sodium, and then the potassium also will counteract, and then going to another protein complexes. Okay, the proton, sodium will come in. The potassium will go out, the sodium will come in, the potassium will, it's just like that the process, and back an electrical signal will be produced. So that is very, very important to eat food rich in potassium, which is banana. Okay? And but magnesium also. Okay? That is very, very obviously from banana. Okay? So through that, we can have an ATP. Ano, hindi naman tawa, you said, if you eat banana, makaligon sa buko. Because this will generate ATP, and this have phosphorus in ATP. And phosphorus is very important for the healthy bones. That's why the people who will eat banana every day have a very strong bones compared to those people who doesn't eat banana. That's very clear. Because of the presence of potassium and magnesium. That's can be explained in science. But that's why when we become 60 years, I'm not telling that that's me. When you become 60 years old, 70 years old, your spinal column will not be bended when you walk. Right? So that means you have rich in potassium, magnesium, phosphorus, and calcium as well. You get the point? And you are far from osteoporosis and osteomalacia diseases. And for the children, they are also far from vitamin D deficiency, which is rickets for the children. Okay? But for the adults, that's already osteoporosis. Okay, is the result of the weakening of your bones called osteomalacia. Softening of the bones is osteomalacia. Weakening of your bones, dislocation of the bones, joints, ligaments, cartilages, and everything, that is osteoporosis. Okay, but these are all diseases of the bones due to vitamin T deficiency driven by lack of calcium inside your system. Along with the phosphorus, potassium, and magnesium. Okay, and that's very clear because phosphorus is present in the ATP. Get the point? Oh, triphosphate. Nakakaloka. Di mo lugwa agad siya. Di ba? You get the point. Saan na siya? So, balik ka sa protein complex number 1. Okay. So, what will comes in the protein complex 1? Okay, as I told you, it will never synthesize and generate something, electrochemical gradient, okay, if there's no enzyme that will act on it to catalyze the reaction. So the requirement is enzyme and coenzyme. Okay, so these are the group of substances, usually they are enzymatic protein, one type of proteins. As I told you, I discussed a while ago, there are 7 types of protein inside our body. This is one of the types of protein, enzymatic protein, or enzymes in short term. So meaning to say, it's a protein. Okay, just like we have a antimicrobial protein. So these are all antibodies. Okay, antibodies is also a protein, but antimicrobial protein. That's why it's always fortified in vaccine, because it will recognize and attract viruses and capture that there, and eventually they will be dying for quite some time, and then they can determine that you have this kind of disease related to virus infection. Okay, so the 7 types of protein you should remember. Okay, so I understood already because I discussed that a while ago in the last weeks, right? I differentiate the 7 types of protein. No need to go back, right, guys? Because we will reach midnight in discussing the details. Because the point, things like that. Okay, then kung love giving you ang science, then it's enjoyable. Okay. So I found it kasi enjoyable eh. You get the point? I'm not more on the politics, okay, and humor, joke. I also watch, because laughter is the best medicine, but naturally I love science talaga. You get the point? So we have here. So, okay. Then the electrons here, okay, we have here, the first that will go here is our NADH. NADH coenzyme. The helper enzyme is the coenzyme. Okay, the NADH will go here, intermediate space going to the protein complex. Okay, and then it will be converted to NAD positive. Okay, meaning to say, it is undergoing an oxidation reaction. Things like that. Why? Why mga palangga kung hita? It loses the electrons but increase the oxidation state because it becomes NAD+. Okay, and NADH has no charge. And then it will turn to NAD+. It will become higher in oxidation state, which is positive 1. As I told you a while ago in our discussion, the strategy and technique, if it really increases the oxidation state, which is a charge, then that undergoing the process of oxidation. Okay, that's why reduction is not present here in our electron transport chain. Always oxidation, rapid oxidation. And another reason also, due to rapid oxidation of oxygen, because we need oxygen every second, every minute, so that we can inhale. It gives us energy. Okay, the oxygen. Without oxygen, these things I discussed, nothing. Useless. That's why this is called aerobic cellular respiration, because of oxygen. And this is only the step number 4. As I told you a while ago, in the total summary of this respiration. Meaning I break only. Okay? So this is very lengthy topic. That's why I need to break 1, 2, 3, 4. Because it cannot be done in one setting. It can be done, but you will go directly. You don't need to mention the other, di ba? So you know what I mean. So you are not comprehensive. You will go directly like that. Okay? But I want to be comprehensive. That's why. You get the point? Okay. Now your electron carriers, okay, will convert to protons, and the protons will be pumped here, going to above. Okay, proton here. Now, as I told you, it's undergone oxidation, so this will yield 4 electrons. Okay, and this 4 electrons as our carrier will produce 4H proton. Our electrochemical protein, after it will be pumped there, out in the matrix. Since higher concentration to lower concentration, matuyog din siya ang protein complexes. Okay? Counterclockwise to produce the necessary energy to go in the step 2. Okay. Now, if we in the protein 1 complex and the protein 2 complex, the protein 2 complex will not pump, remember, will not pump the protons directly going to 3. Okay, the protein complex 2 wait for the result of the protein complex 1. So they will be collaborating with each other. Now, the electron carrier here of your protein complex 1, okay, will be added or be activated with a coenzyme Q, as I told you. Okay, this coenzyme Q will capture this protein complex electrons, and they will be combined with each other, and then the protons that will be released after capturing the electrons of this protein complex number 2 will be pumped out together, 1 and 2 protons, and it will be going to the protein complex number 3. Okay, but before going to protein complex 3, musugat niya or mo-activate niya ang cytochrome enzyme, cytochrome C enzyme. Okay, and the cytochrome enzyme will activate, okay, the products of these 2 and 3 protons going to 3, things like that. But remember, in the protein complex 1, 4 electrons with these 4 protons, and then this is through NADH, coenzyme helper. Okay, in the 2 protein complex, this is now NADH2, okay, 2FAD, positive, like that. Okay, now again, oxidation. You get the point? But in here, only 2 electrons, because we have already the subscript 2 in the hydrogen. So 2 electrons will go to the protein complex, then it will yield, okay, 4H protons also. These 4H protons will go to your 3 to be pumped out again with a pump of 2, 1, 2, like that. It will go to the 3. The 3 protein complex, the story is just like that always. Okay, but in the 3, we don't need anymore this 1, but directly the cytochrome C. Okay? Meaning to say, we don't need the other collaboration because it's combined 1 and 2 already to go to 3. Okay? Things like that. And your protons will be now 2H na lang siya. Okay? So 2H na lang siya, may gamay siya. Na-siya yung purpose na nung gamay siya because here we have an oxygen acceptor na nagpaabot diri. Oxygen acceptor. Oxygen electron acceptor. Here, in the 4. Magpaabot siya dito. Okay. And then the electrons produced by protein complex number 3 will yield also proton. That will be going to the number 4 protein complex. Okay, it will meet this ATP synthase and then ATP well produced. Okay, but before going to the ATP production, okay, it will release the 4, okay, 4, ano siya? 4H, 2H, balik siya sa 4H. Okay, naku siya balik. Okay, so 4H, I cannot discuss that here because we don't have enzyme here in the 3. Okay, but I can show the reduction oxidation chemical reaction. So after here, it's in the 4, the electron oxygen acceptor will combine the oxygen. So oxygen gas, okay, plus hydrogen. Diba? Ana na siya. Oxygen gas plus hydrogen. Because your hydrogen is positive, this is the proton. The proton where we're thinking is all the time in the pumping is the hydrogen. Okay? Hydrogen plus. So this is the proton we mean here. This is electrochemical gradient. Electrochemical gradient because we need electrical signal, this energy to pump. If there's no electrical, how can it go out in the protein? Mupilit sila dito. So that's why there's an electrical signal in order these protons will go out. Right? So wala silbi. If there's no electrical activator, nakakaloka. You get the point? Ganon siya. Okay, and after oxygen plus H na siya, no? Okay, so we did release 4H again here in the 4. So, ano na siya? O2, nakakaloka, di ba? O2 plus 4H is equal to water. Because you will produce 4H here in the 4, right? So, then balance the chemical reaction. O, ganun yun. 2 moles of H2, 4 hydrogen, 4 hydrogen, balance na yun siya. Automatically, balance na yung siya. Okay? You get the point, mga palangga pungitan. So, oxygen gas plus hydrogen is equal to water. So, if we don't need protons yet, natural state, we can have 1/2 oxygen gas is equals to 2 moles of water. Things like that. Okay? Okay, hydrogen will be 2. So, put 2 here. Ganon. Okay, so 2 hydrogen. So 2 hydrogen. Okay. Oxygen 1, oxygen 1. Hydrogen 2, hydrogen. It's going to be 1/2 oxygen gas plus 2 moles of hydrogen plus, I'm not saying gas ha, hydrogen only, so that's why I do not put 2 sa script. So 2 moles of hydrogen is equals to 1 mole of water only. Then, since our protein complex number 4 will produce 4H, that's why our chemical reaction will adjust to oxygen gas plus 4 moles of H positive is equal to 2 moles of water. Things like that. You get the point? So, and after that, the electrons that will be captured will also meet and activated by the last ATP enzyme, which is F1, F0 ATP synthase. Okay, ganun siya. Okay, and then it will activate the proton electrical chemical gradient that will be released in number 4. Okay, and then it will synthesize ATP from ADP and inorganic phosphate, as I discussed a while ago, in my introduction. Okay, so the final stage is the ATP synthase enzyme that will produce an ATP synthesis. Okay, so ATP will be synthesized from adenosine dinucleotide, okay, and then, okay, ADP plus inorganic phosphate is equals to ATP. Ganun, discuss naman ako siya kanina. Kung na makakuha din tag ATP. And then, nasa siya yung water din ari, so water and ATP. Now, if we go back to our general equation, glucose plus 6 moles of oxygen gas is equals to 6 moles of carbon dioxide plus 6 moles of water plus ATP. So, ipasok sa banga ang water and ang ATP. Okay. Now, why we have only 2 here? Because we are considering only the single cell. Things like that. Okay. Now, we distribute the CO2. The CO2 in your product coming from the centric cycle is step number 3. On the Krebs cycle, you can generate carbon dioxide there. Okay. But in here, in electron transport, we don't need carbon dioxide, only the water and the ATP. That's why your chemical reaction overall, there's an ATP, water, and CO2. So the production of CO2 is the job of your citric cycle, citric acid cycle, and the Krebs cycle. And the production of water is the job of your electron transport chain. Like that. So in short, your electron transport chain will produce reactive species of oxygen. This is the O2. Okay, and will yield hydrogen, water, and then ATP, and it goes back to the cycle again. From the first, like what it says, balik na po siya sa uno. That's why it's a cycle. This cycle is natural. Daily add tool every second, every minute to individual. This is only single cell in the vital organ. So makabuang no, because this is only one single cell siya sa, for example, if this is a liver, one single, there's trillions of cells in the liver. And again, kidney, trillion cells of the kidney. Imagine how many cycles that it will be creating inside our body like this. You get the point? So many, right? Okay, but the target in each cell will produce 38 atoms of ATP. So in summary, mga palangga, kung hitag, so it's gonna be like that. No, we don't have to be, exact all the time. So these are only the details. Okay, that's the point. Hanahanap siya. Okay. Now, in short, guys, in your electron transport chain, ganon, you will produce at least 26 to 34 ATPs. And then in your overall aerobic cellular respiration that includes the steps, the 1, 2, 3, 4 steps until etc. Okay, you can get 30 to 38 ATP. Now, if you are less than 30, abnormal. Okay, if you're more than 38, again also abnormal. Okay, so it should be in the range between 33 to 38. Okay, so if less than 30, so a lot of diseases comes in. If more than 38, there's a lot of diseases come in. So at least it is in the range for a normal person to have 30 atoms of adenosine triphosphate to 38 atoms of adenosine triphosphate, which is the main source of energy in our single cell or one cell in our vital organ. Ganon. Any questions so far? Diba? Okay. But before that, ang daming pasada. Ganun talaga di ba? Before that, it really is very broad. It comes from the nature, like this, and it goes to glycerol. Okay, glycerol is a sugar alcohol, natural alcohol we have in our system. Okay, plus 3 fatty acids. Okay, like that. Okay, 3 fatty acids, and it will produce the coenzyme acetyl-CoA. Okay, this acetyl-CoA coenzyme, dili pa lang siya, yield na siya ganun kayong mga ATP. Okay, 91, ganun. Okay, 91 ATP. Okay, and then for NADH, we have 21 ATP. And for FADH2, we have 14 ATP. Total ko siya, guys. So, mo na siyang yung total niya. 2 plus 4, lang ganon. So, we have a total of 21 plus 21 mga palangga. Kung hitag, 111 plus 40. It's gonna be more or less 125. It's gonna be like that. Tama ba? Okay. Basta mo na siya yung yield more than 100 plus ATP. If you add this 3, and then it will be reduced somewhere else in going to the ETC. Okay? We don't need this one because in this cycle here, this is all about fats. Okay? Because acetyl-CoA is very useful in the production of fats and cholesterol, and we don't want too much like this. That's why this 100 plus ATP will need to be reduced somewhere in the end, which is now 38. Okay? So this is the initial, okay, situation from our ATPs. Ganon. Diba? Nakakaloka mga palangga kung kita. Okay? So any questions so far for this, electron transport chain explanation? And this will be the last of our biochemistry vlog. I'll be coming back next week, okay, for all about English. Okay, it's gonna be listening, reading, and writing vlogs. Okay, so no more science at this point. Let's rest a little bit with science. We go to English. Okay. And after English, we will go a little bit with safety, huh? Safety. I will make it on the last because that is my career. It talks, to be honest, it looks like boring. If you are always on that kind of specialization or career path, and then there's no such challenge anymore. You get the point? Things like we need to learn another thing. You get the point? I don't know, maybe it's just me. So we need to learn other things also, rather than only one specialization. You get the point? Ganon siya. So, okay, napilit naman siya sa brain cells. Okay? You get the point? So, dali na siya pag-discuss. Okay, ang safety. Okay, so, atong i-focus ang English. Okay, next week. And English now is for everybody. Okay? That's not only related to science professionals. So anyone can relate for English. Okay? It's gonna be like that. Okay? That would be better, right? Because applicable to... Science also is applicable for all, but it looks like tiring, very... What do you call this one? Mentally stressed. So many... so many information. Okay? And technicalities. Whereas English, we can adjust that. It's only like this, grammar, vocabulary, like that. Okay. I don't know, maybe it's just me, but it's easy to manage if you try to vlog English in my part. Okay. I'm not majoring in English, but I'm comfortable. Okay, to vlog in English as well. You get the point? Anak siya. Thank you so much for watching. I hope you can share it to anybody else for this particular discussion all about ETC, Electron Transport chain, which is the last step of our aerobic cell respiration. You can also comment down below in the comment section. You can like, you can share, and you can even subscribe my YT channel if you haven't yet subscribed my YT channel. I will be very, very happy and grateful to that. Okay, and then you can also click the notification bell for some newest updates of science, health, safety, and music YT channel. Bye-bye everybody, God bless. See you later. Nakakaloka, ibang. Ganon, yes. Nako, mga pala kakahitan. Lisa, mo pala dyan ko sa biochemistry. Wow, I love it. Diba? Ganon. Charach lang. Chararat, mga kapatid kong hitad. Muna ay nahitabo karong adlaw. Charas. Uy! Nakalimot siya ko close eye. Fairness! Chararat kaayo, no?